Hello, everybody. It's Mrs. Pound, and we're on chapter 26 about sound. Today, our objectives are going to be to give examples of force vibration and describe conditions for resonance. So, section 26.6 is on forced vibrations. So, what are forced vibrations? A forced vibration is the vibration of an object that is made to vibrate by another object that is nearby. Stringed instruments use this all the time. When you pluck the string of a guitar, it really wouldn't sound like very much if it didn't have the body of the guitar to vibrate with it. And so it causes that vibration, it amplifies the vibration. We call that a sounding board. So, violins, cellos, all of your stringed instruments have a sounding board. Another example is also a music box. A music box is mounted on a sounding board. If it was not mounted on a sounding board, it would just sound like little plinks that you could hardly hear. So, stringed instruments, music boxes, all kinds of things use sounding boards to amplify the sound. Objects also have natural frequency. Natural frequency is a frequency at which an elastic object, once energized, will vibrate. The minimum energy required to continue vibration at that frequency, and also called resonant frequency. As we can see, I have some tuning forks in the background, and they have natural frequencies. When they are struck, you can hear the difference in the frequency. They have different sounds. They're made of the same material, but because they have different sizes, basically different shapes, they have a different frequency. So that is one of the things that affects it. Now, almost everything that exists has a natural frequency. For example, if you drop a penny on the floor, you pretty much know that sound. You identify that as a penny sound. And so pennies have a natural frequency. There are many things that when you drop them on the floor, you recognize that sound because they have a certain natural frequency that is recognizable. Now, natural frequency does depend on elasticity. This does not mean the amount of stretchability. It's not stretching, it's actually how it bounces back. Okay. And shape. Like I said, with the tuning forks, they have a different shape. So on this xylophone, all of these keys are the same material, but they're different sizes. So that gives them a different natural frequency because of their shape. Now, there's also a property called resonance that's really interesting with sound. You probably have not heard of this term before, but you know of it. Resonance is a phenomenon that occurs when the frequency of force vibrations on an object matches the object's natural frequency, and a dramatic increase in amplitude results. This is the classic opera singer breaking a crystal wine glass example, where when the opera singer hits a certain pitch, a certain frequency, the crystal shatters. That is because of resonance, that the opera singer's voice has hit the right frequency, that it causes this natural vibration that increases the amplitude and shatters the crystal. Some other examples are tuning a radio. When you change the receiver on the radio, you are tuning it to the same frequency as radio waves in the air, and that allows resonance that vibrates the radio and produces the sound that you hear coming through the radio. As I said before, shattering a crystal glass. And we are going to see an example of resonance with a bridge where the wind blew at just the right speed to produce the right frequency to actually cause a bridge to collapse. And we're going to watch a video of that in class. And if you're curious, you can even look it up yourself beforehand. So, our objectives today were to give examples of force vibration and to describe conditions for resonance. So, don't forget your 5 questions, and I'll be back with one more video about sound.